Boeing's new 777X is a masterpiece of American engineering, boasting folding wings and engines more powerful than a space rocket. So why did the head of Emirates Airline just call this nearly $500 million marvel a can of baked beans? Today, we will decode the turbulent journey of the 777X. It represents the absolute future of aviation, but blown cargo doors and intense scrutiny from the US Federal Aviation Administration have turned its rollout into an endless nightmare. The 777-9 variant is officially the longest twin-engine passenger jet ever built. Clocking in at 251 feet 9 inches long, this aircraft shattered the record held by the 747-8, kicking off a new era for long-haul aviation. Its most unprecedented feature for a commercial airliner? The folding wingtips. To maximize fuel efficiency on ultra-long-haul routes, the 777X's wingspan was stretched out to a massive 235 feet 5 inches. That immense width generates incredible lift, but it totally exceeds standard airport gate limits. Boeing's solution: integrating an 11-foot folding wingtip mechanism. When taxiing on the ground, the tips fold straight up, shrinking the total span down to 212 feet 9 inches. This engineering breakthrough lets the 777X integrate seamlessly into existing terminals without requiring a single dollar of infrastructure upgrades. The FAA regulates this mechanism strictly. The wings can only fold when ground speed is under 50 knots. If the flight crew attempts to fold them mid-flight, the flight computers will trigger a hard lockout. This massive wing structure is manufactured out of carbon fiber reinforced polymer in giant pressurized autoclaves at the Everett, Washington plant, giving it exceptional durability and flexibility. The power behind this giant comes from a pair of General Electric GE9X engines. We're talking about the largest, most powerful commercial turbofan engines ever created. Its Guinness record-breaking thrust of 134,300 pounds delivers more power than the rocket that sent Alan Shepard to space. The front fan alone spans 134 inches across, as wide as the fuselage of a 737. Its 16 carbon fiber fan blades look like a work of art, but they can withstand a high-speed bird strike while maintaining structural integrity. Deep inside the core, it sets an unheard-of record: a 60-to-1 pressure ratio. That massive pressure, built up in milliseconds, is equivalent to the full weight of the ocean almost 2,000 feet down. Paired with hundreds of 3D printed parts and CMC ceramic materials, the combustor can handle temperatures over 2,370 degrees Fahrenheit, hotter than volcanic lava. Thanks to this engineering, the GE9X burns exceptionally clean, cutting fuel consumption and emissions by 10%. Despite its raw power, the 777X is incredibly quiet. The composite nacelle absorbs the noise, cutting takeoff roar by 40%, landing 8 decibels below the international Stage 5 limits, creating a quiet cabin for passengers. However, this propulsion system was ground zero for the crisis. During testing, the FAA halted the project when they discovered severe wear on the stator vanes inside the GE9X compressor. This forced Boeing and GE into a major redesign, delaying the entire timeline. To power this titan across continents, the 777X is equipped with a massive fuel system deep inside those carbon wings and the center tank, holding an impressive 52,300 US gallons. Fully loaded, that fuel weighs approximately 350,000 pounds, which is equivalent to the maximum takeoff weight of a modern mid-size airliner. This immense fuel capacity lets the 777X effortlessly fly non-stop routes, stretching from 7,285 to well over 8,745 nautical miles. With a maximum takeoff weight hitting 775,000 pounds, the landing gear requires absolute precision. Even though it's designed to replace giants like the Airbus A380, The 777X's main gear is much leaner, rolling on just 12 wheels compared to the A380's 20. To distribute that load without damaging the runway, it is equipped with an aft axle steering system. When the jet makes a tight turn on the tarmac, the rear wheels turn in the opposite direction. This advanced feature eliminates tire scrubbing, saving millions in routine maintenance costs. Inside the cabin, Boeing sculpted the sidewalls as much as possible while maintaining top-tier insulation and soundproofing. This makes the interior almost 20 inches wider than the competition, giving airlines the flexibility to offer wider seats or roomier aisles. Up in the flight deck, the 777X is the first wide-body commercial jet to feature a fully touchscreen interface. Pilots can navigate through charts just like an iPad, reducing hardware and streamlining operations during an emergency. Passenger comfort is elevated with active turbulence-canceling technology. Ultra-sensitive sensors on the nose constantly scan the air ahead for rough patches. Instantly, the central computers adjust the trailing edge flaps in a fraction of a second to counteract the bumps. Combine that with advanced features inherited from the 787 Dreamliner, like oversized push-button dimmable windows, higher cabin humidity, and cabin pressure set to a comfortable 6,000 feet, and you get a highly relaxing flight environment. Even with these technological breakthroughs, getting the 777X into commercial service has been a grueling journey. The program launched back in November 2013, aiming for a 2020 delivery, but it's been pushed back repeatedly, all the way to the 2025 to 2027 window. The main obstacles? Rigorous FAA safety audits, plus unpredictable technical glitches emerging during engine and structural tests. The most critical setback occurred in September 2019 during the FAA's ultimate load test. When the wings were bent up to their absolute breaking point to test structural integrity, the extreme pressure ruptured the airframe, completely blowing out a cargo door. That catastrophic failure forced Boeing to heavily reinforce the fuselage, consuming billions of extra dollars and delaying the project for years. The complications did not stop there. The aftermath of the 737 MAX disasters put the FAA on high alert, causing them to scrutinize the 777X's avionics and flight control software with unprecedented strictness. When the flight computers triggered an uncommanded pitch event during a test flight, altering the nose attitude without pilot input, the FAA instantly grounded the certification flights. Boeing was forced to rewrite lines of code and completely redesign the warning systems, extending the waiting period even longer. Despite these extensive delays, the Boeing 777X holds on to its strategic mission. Its largest customer is Emirates, holding a massive order of 270 aircraft. But patience is running out. Recently, Emirates' leadership firmly declined to take delivery of 10 777X jets from the initial production batch. That hardline move put the pressure on Boeing to ensure absolute precision on the assembly line. And that's exactly why President Tim Clark dropped that bitter criticism. To him, 10 brand new aircraft that had to be structurally modified and practically obsolete before they even left the ground were no better than cheap baked bean tins. Still, the 777X remains a strategic powerhouse, purpose-built to completely phase out the aging 4-engine Airbus A380s. The Boeing 777X is the living proof of American aerospace evolution. It might have started as a crisis, but once it clears the FAA gauntlet, this machine is bound to command the skies for the next decade.